So this is problem 1, week 2, and this deals with vectors. And you can see that what they're asking you to do here is basically decompose the existing vectors into their components. And one of the things you got to think about when you decompose vectors is that they could be decomposed into a lot of different things. Now, for our purposes in building construction, we'll always decompose, or almost always decompose, vectors into horizontal and vertical components. And that's because gravity acts vertically and wind and seismic loads act horizontally. So we always conceive of a building as being a series of vertical and horizontal forces. So specifically, if we look over here at example A, they're asking for the x and y component of this vector. Well, notice that it's straight horizontal, which means there is no y component, and the x component is exactly what it is. So the x component of this vector is just simply 15 pounds. And I guess so that we can be clear, we can say that x equals 15 pounds. And note that it's positive 15 pounds to indicate a direction to the right. So just a little bit about coordinate system. We would consider coordinates in this first quadrant here to be positive and positive. Coordinates in the second quadrant are negative in x and positive in y. Coordinates in the third quadrant are negative in x and negative in y, and coordinates in the fourth quadrant are positive in x, negative in y. Well, there is no y component to this, so it's just a positive x. Now, this vector is made up of x and y components, and so we have to decompose it. So we're going to break this thing into a horizontal component and a vertical component. And you'll notice that the way that I've drawn them, the vectors are head to tail, which this is really kind of the opposite of adding vectors. You're trying to resolve them into components. So the question is, well, let's think about the y coordinate. How could we figure out the length of this vector? Well, notice that the y component of this vector is opposite the angle. And we know the hypotenuse, so that means we can use basic trig functions. So if we think about our basic trig functions, so, ka, toa, and the question is what relates opposite and hypotenuse, because that's opposite is what we want to know and hypotenuse is what we know. Well, it's the sine, right? So what do we know? Sine of 63 degrees equals opposite over hypotenuse. The y length divided by 27 pounds. Well, that means that 27 pounds times the sine of 63 equals y. So let's just use our calculator and look up the sine of 63 degrees. So 63, we're in degrees mode, sine 0.89. Okay, and we're going to multiply that by 27. And we're going to find that the y component of this is about 24, we'll call it 24 pounds. Now, this drawing is not to scale. If you notice that this included angle here is 63 degrees, which in the real world would mean that y is going to be larger than x. But you can see that because they haven't drawn it to scale, it gives the impression that x is a larger value than y, but it really isn't. So if we wanted to find the x component, well, the x component is adjacent, and we could use tangent and relate tangent. We could relate opposite and adjacent, but remember that this y was calculated, so we'd prefer to take a given number. So we want to relate hypotenuse and adjacent. So the function that does that is cosine. So, okay, again, the cosine of 63 degrees equals what? Equals adjacent over hypotenuse. So x over 27 pounds, or again, 27 pounds times the cosine of 63 in this case. Remember, last time it was the sine, equals x. So again, just pull it up on the calculator, clear 63 degrees, yes, we're in degree mode, take the cosine of it, and you can see that it's the cosine is less than the sine because we're at an angle greater than 45 degrees. So we would expect that the value for x will be less than the value for y. And then how do we solve for that? We take that number, that cosine of 63 degrees, and we multiply it by 27 pounds. And we find that x is about 12 1/4 pounds. And again, you could think about kind of reasonable limits, right? That you know, if we had two components pulling to the right, they would sum to 27. If you had two components pulling opposite each other, they'd sum to 0. So basically, no component can be more than 27, and no component can be less than 0. So our answers check out here. Now, for problem C, they have you working in the third quadrant, and this can get a little bit messy because they're showing the angle from this line, but remember you have another 180 degrees here. So you either have to transform this, which would mean basically rotating this thing back 180 degrees and then work in the first quadrant, and then you have to remember to manipulate the signs to get the answer they want, or you have to add 180 to the angle that they've given. So that will be our strategy. Again, we're looking for the y component, that's the vertical component, and we're looking for the x component, right? So the x component pulls left, the y component pulls down. The angle in this case is 57 plus 180, so 237 degrees. So again, to find y, sine of 237 degrees equals opposite over hypotenuse. And they've told us, they didn't label it in the drawing, but they've told us the hypotenuse is a distance of 15 feet. So opposite is y over 15 feet. 15 feet times the sine of 237 equals y. Now, if you think about vector y is pointed downward, and the way that gets denoted mathematically is that the force number we get, or the distance number we should get, should be a negative number. So that tells me 15 is positive, sine of 237 has to be negative. So if you punch this up and you get a positive number, you have to take a look at it. So 237 sine, and yep, there we have a negative number. We're going to multiply that by 15. And you can see that distance 12, or coordinate 12, we'd say, is like negative 12.6. Now, you know, you got to think of this as kind of a relative distance, or a relative position, right? There's no mark on the tape measure for negative 12 feet. What it's saying is 12.6 feet below x. It's negative in the coordinate system. The distance is not negative, the location is. For x, again, we're going to relate the hypotenuse and the adjacent side. So cosine of, and again we have to use that large angle to get the x numbers to work out correctly, because x is also going to be negative, right? We're left of 0. We can think about this location here, that origin, as being coordinate 0, 0. So x is going to be a negative number. Cosine of 237, what does it equal? It equals adjacent, which is x, over the hypotenuse, which is 15. So again, it's 15 times cosine 237, and we're going to get a negative number. So 237, and we'll take the cosine of it, and I know that the cosine will be smaller than the sine because this angle here is greater than 45 degrees. So 237 cosine, and then I'll multiply that by the length times 15. So the coordinate of this point is negative 8 point. We'll call it negative 8.2. Now what that means is you're going to go left 8.2 feet, then you're going to go down 12.6 feet, that would be equivalent to going diagonal 15 feet, because the units for this problem are distance. Be the same thing with forces. You pull to the left with 8.2 pounds, you pull down with 12.6 pounds. That is equivalent to pulling down and to the left at a 57-degree angle with 15 pounds. Finally, last problem here, problem D. Similar scenario, right? We're going to identify an x component, and this x component is going to be positive because the pull is to the right, or the distance is to the right, and a y component. The y component will be negative because we're moving down. So y and x. And you'll notice that they've shown this as negative 39 degrees. Well, 0 degrees is here, and we proceed our way around the circle in this direction. And all of the trig functions are based on degrees from 0 proceeding counterclockwise. So one way to get this angle is you could take 360 minus this angle. So you'd find that effectively, this angle all the way around from 0 to here is 321 degrees. Okay, so that's what we'll use for our functions. So again, we're trying to relate opposite and hypotenuse. We know that hypotenuse was 18 feet in length. That was given. So sine 321 degrees equals y over the length of the hypotenuse, which was given in the problem as 18 feet. And plugging and chugging, 18 feet times sine of 321 degrees equals, and again we know that this is going to be a negative number because the y-coordinate is negative. So 321, and we'll take the sine function of that, and then we will multiply it by 18. And we see that the distance is about negative 11.3 feet. Or I should say the position is negative 11.3 feet. The distance is 11.3 feet in a downward direction. To find the x component, notice x is going to be positive here. Same process, right? Cosine 321 degrees equals adjacent over hypotenuse x over 18. So one of the things you may have noticed is that if we're moving left to right, we're always using the cosine function, and if we're moving up and down, you're always using the sine function. And after a while, you will come to associate cosine with left and right and sine with up and down automatically, because you're going to see it over and over and over again in these problems. Doing a little plugging and chugging, we multiply both sides by 18. 18 times the cosine of 321 degrees equals x, which is equal to so we'll come out of here again, 321 degrees cosine times 18. It should give us a positive number, less than 18, which it does. 13.99 feet, let's call it 14 feet even. 14 feet even. So there we were able to solve for all of our variables in x and y, and it's basically just a matter of getting the problem set up right and then turning the crank to find the values. I hope this helps. If you have any questions, as always, please feel free to contact me at the contacts listed in the course syllabus.